Hello guys, so in this video I'll talk about what is cert-manager and how to set it up on Kubernetes, and we'll also do the full setup in this video itself. So we'll be installing cert-manager on Kubernetes. By the way, if you're new to this channel, please hit the subscribe button and also hit the bell icon so that you can get notifications about all of my new videos. So cert-manager is used for issuing new certificates or renewing of the certificates for your domains. So in this example, like suppose you have a domain foo.bar.com, right? And or something www.example.com or like some other domain. And now you want to run or expose these domains on HTTPS. When you expose these on HTTPS, you need to have a secure certificate. So cert-manager automates the full process for you. So when you install cert-manager in Kubernetes, it would help you in issuing new certificates and also renewing the certificates for you before they expire. So cert-manager.io explains the full step, like it explains what cert-manager is and also explains the installation steps, and we'll do all of these installation steps in this video. So it says that how do you install it on Kubernetes. So when you're installing it on Kubernetes, you can install it using kubectl. So you say kubectl apply -f, and this is the file which you need to apply. When you try to open this file, so it's downloaded here, and I'll copy it and show it in my editor. So this is the file which gets downloaded from cert-manager. You can see like it's like around 25,000 lines of code, right, that gets added to Kubernetes. So you don't have to go into all of these details, but this would install cert-manager inside your Kubernetes cluster. So after installing the cert-manager, we need to configure the cert-manager to start issuing certificates for us. So let's go to the configuration now. The very first thing we need to do is we need to tell that what is a cert issuer. So you could use various types of issuers. You could use a self-signed, CA or all. So we'll be using ACME type of issuer, which is like one of the most famous ones. And in ACME type of issuer, there are various mechanisms using which your domains could be challenged or could be validated by the issuer. So we'll be using the DNS01 type of the mechanism. And when you're using the DNS1, when you select here, you could select the provider which you're using, right? Like means like the cloud provider. So I'm using AWS, so I select Route 53 for the instructions. So we'll do all of these steps in the code. So then it also explains the steps if you are using EKS and how exactly you set it up for EKS. So in this video, I'll be using kops to set up the Kubernetes cluster, and the next one I'll also show it on the EKS, like if you're setting the Kubernetes cluster using EKS. So I'll be using kops for setting up of my cluster, and here is all the code that I'll be using. So the link to all of this code would be in the description below. So the very first thing that we'll do is creating of the cluster. So this is the make file. I'll be executing commands from it. So first thing I'll do is create the cluster, which uses kops and creates the cluster using this cluster.yaml. So when we look at this cluster.yaml, it's a huge file, but nothing fancy. Like this is all the default configurations. The only configuration that I add is that I add a cert-manager and I enable is equal to true. That's the only one. Rest, like you could just use all the default configurations and it would work for you. You don't need to use like the cluster.yaml file, but the only thing is after you create a cluster, you'll have to edit it and then add the cert-manager and enable is equal to true. And this is only if you're using kops. If you have a custom cluster or if you're using EKS, you could install like all of the cert-manager stuff using the cert-manager YAML file, which we saw already on the cert-manager.io link. So let's go ahead and create a cluster. So the make cluster is executing this command, which is like all these 4 commands, creating of cluster using kops, and then it creates a secret name, which is basically copying my public ID, like the public SSH ID, so that I can log into the nodes and all if I want. And it says that I want to, so when we say kops create cluster, the cluster is not created, but we have to call kops update cluster and --s. This actually creates the cluster. And then we are setting up of the kubectl, that is kubeconfig, so that we can execute kubectl commands and deploy our code and all. So after the cluster is created, the next thing, like right now, the cluster has just been like the process is started, but the cluster is not up. We can say make valid cluster, again the valid cluster is this command, which is kops valid cluster. So here you see like all of the stuff has been issued, but it takes around 10 minutes for the cluster to be up and ready. So I'll pause the video for 10 minutes and then we'll start from there. So after the cluster is created, we'll install like a couple of applications. So one set of applications is on the left, which consists of 3 pods. This would be a deployment, and the domain for that would be foo.jomo.click. So jomo.click is the domain which I'll be using for the cluster. And then another subdomain which is bar.jomo.click, which will have a different set of deployment. And this would be exposed using the ingress service. So all of the traffic would come from Route 53. From Route 53 it will go to the load balancer, and then the ingress would be used to send the traffic to these various pods. So if you're just exposing our traffic on HTTP, there is no need to install cert-manager. But since we want our traffic to be exposed, like we want our functionality or application to be exposed over HTTPS, we need cert-manager to issue the certificates for foo.jomo.click and bar.jomo.click. So let's look at the code for all of this, which is the applications and also the ingress service. So here is my application. So basically it says that this is a deployment, and we say that we'll be creating 4 replicas in the deployment, and we say that we will be using this image, which is Robin Nagpal Kubernetes tutorial. So this image, all it says is like we'll hit the URL and we'll get what is the app name as part of the response, right? So it will say that the response is being served from the app, which is foo. So, and this we pass the app name as environment variables. So we declare another deployment, which is bar, and for the bar we say the app name is bar. Rest of the stuff configuration is exactly same. The deployment is different. The deployment would be bar backend. And then we have a service here. So this is the bar app service, which points to this pods, right? Because the selector is bar app, and the port of the service is 3000, and the target port is also 3000 because the app runs on the 3000 port. And when we look at ingress, so this is the ingress which we'll be using. So initially we'll not have any TLS and all, which is no HTTPS. Initially we'll just use HTTP, and within HTTP, like even if you're exposing HTTPS or HTTP, like you in ingress you just declare it as HTTP, and below you tell like what are the HTTPS hosts you want to declare and what is the secret, that is where your certificate will be stored. So since there are no certificates now, I've just commented out, this will be used later on. So I expose 2 domains. One is foo.jomo.click, and which will be served from this service, foo app service, and there is bar.jomo.click that will be served from the bar app service. So let's see whether our cluster is up and running now. So we need to wait for a few more minutes for the cluster to be up. Until the cluster comes up fully, let's look at the permissions that we need to provide to the cert-manager. So cert-manager needs to create few DNS records on Route 53 in order to validate that we own the domain. So for that we need to give certain permissions. So this is the policy that will be used for creating or like changing the resource record sets of Route 53. So we'll create a role which would be cluster manager, and then we'll assign this policy to that role. So we'll create a role which is cert manager. So we'll assign that policy, and then we'll add a user, and to that user we will assign another policy that they should be able to assume that role, which is cert manager. And that user will be using here in the selectors, which will be DNS zones, and then here we need to give access key ID, like the access key ID of the user, and the secret, which will be access key secret of the user, and that will point to a secret that we'll create. So here I am open. So if you see, I already have a user which was cluster Kubernetes cluster creator. I used this user to create the cluster, but for adding the DNS records and all, or like the user that will be used in the cert manager would be this one, which is Kubernetes cluster user. Right now this user does not have any permissions. That's why we see that says get started with permissions and all. there is no role which is cert manager, so we'll be creating that role. So we can do all of that manually, like through web console, but I'll use a terraform script which makes it a bit easier, and also attach the terraform script in the description below, so that if you want to execute it, you can just run the terraform script. So here is the script which creates a cert manager role first, and then it declares this policy which we saw was the which allows changes to Route 53. So we'll link that policy to the role. Here we are attaching the policy to the role. The role is, this is the policy, and the role is cert manager. And then we create another policy. This is for a user to be able to assume a role which is cert manager, and then we link this policy to the user, which we saw right now the user does not have any permissions, which was Kubernetes cluster user. So let's apply the terraform script. So our script is applied now. Let's look at the resources that are created. By the way, if you're liking the video so far, please subscribe to my channel and hit the like button, because it motivates me a lot. So if you look at the users and we look at this cluster user, now it has a permission, that is, it is able to assume a role. If you look at the policy, so it is able to assume the role, and the role name is cert manager. If you go to the roles, so the cert manager role is created. It has a permission for all of the Route 53 stuff which will be needed by the cert manager. So we'll provide details of this user to cert manager. So let's see whether our cluster is up. Make validate cluster. So it's running like kops validate cluster. So cluster is all ready, and let's try to set up the application first, which for which we'll be setting up TLS or HTTPS. Let's try to set up HTTP. So okay, so I have a customize here which will set up like this. It just executes this foo application, then the bar application, and then it initializes the HA proxy ingress controller, and then it will apply the ingress YAML. So ingress YAML, again, like we have two applications, foo and bar. So customize is an easy way to apply all of these together, but you could just do it one by one, applying each script. So these resources have been created. Let's look at Route 53 and all, and we should see new routes that have been defined corresponding to our services. Ingress, so we have like foo and jomo.click. So let's try to see whether our app is up or not. So it's going to take a few minutes, and I'll pause the video for our app to be up. So our app is up now. So we say hello world right from app foo, and this is foo.jomo.click. Let's reload. Like we just see the counter would increment to one of the pods. Like as it goes to the same pod again, the counter increments. And now when we say bar, we'll see the app loaded from bar. Right, it says from app bar. Again, it's the same container, but like different application because different environment variables and all. And now if we try to use HTTPS, so you see HTTPS fails, and HTTPS for foo also fails. So that's what we'll try to set up now. So to install, like to enable HTTPS, we need to install the cert manager. For me, it's already installed, but you can run the kubectl apply or using Helm. The instructions are already there. And after you apply that, we need to first create the secret that would be used. So I'll create a secret. So the secret is created. Again, this secret would be used in this issuer. So this is the issuer that we'll be creating, which is let's encrypt, and email. So this is the user ID, the access key ID, and this is the secret which I use. And so it says this is the server for let's encrypt it needs to use, and this server would be validating my domains. So we say that we want to validate these DNS domains: jomo.click, foo.jomo.click, bar.jomo.click, and this is like this is the issuer, which is cluster issuer. The name is let's encrypt, which is let's encrypt here, right? And this is the certificates that we want. So this creates request for the certificate and all. So let's apply this. And before we apply, you can also see the DNS records and all. So if you see route 53, right now, these are the DNS records that we see. We'll see more number of records that will be created by cert-manager, and that will be called by the let's encrypt server to validate our domain. So there are few resources that are created. So the resources that we get created is certs, like cert requests, orders, and challenges. So I'll be using K9S tool, which is similar to kubectl, but gives me like a full picture of what's going on. So if I go to namespace, which is all the namespaces, so my cert manager is installed in kube system namespace, which is the pod which listens to the cert manager and all. So if you get stuck, right, go to the logs and see what is happening. So here it says challenge in work and all, right? So you could see like any errors and all which you get, you'll come to know about those. And then you could also, I'll go to namespace, which is default, and here if you click on order, you should see the orders which you created, like for all the namespaces and all. And if I create on cert, so I see this certificate. If we also go to route 53 now, so we see these challenges which are jomo.click. So this works now, right? So like it creates a new DNS record and all. So it adds this tx file and all. So this is used by the cert manager and the issuer to validate our domains. So now we will apply our ingress, which enables HTTPS. So let's apply the ingress. So in ingress, we will uncomment the TLS part, and we'll say that the hosts are foo.jomo and bar.jomo, and we'll say the secret is TLS keys. So this, if we again refer to the cert issuer, so we were creating the certificate, and we were seeing that this is the issuer, and this is the secret where we want to store the certificate. So just remember to use the same secret name. So we apply this. Let's see, it might take some time for HTTPS to be up. So let's hit the browser and see. So if you see now, like here I have HTTPS in the browser, and I could also say bar on HTTPS. So you see how easy it is to configure HTTPS using cert manager, and whatever certificates needs to be renewed and all, cert manager will take care of it and renew those for you. So if you like this video, give me a thumbs up and subscribe to my channel because it motivates me a lot to make more such videos. Thank you.